Alright guys, we're going to start learning about estimating. And estimating is, it's not just guessing, but it's coming up with an answer that is kind of close to the actual answer. We may not want to know an exact answer, but we might want to get close to an answer to help us solve some things. We may want to know about how much something is, but do not necessarily need to know the exact answer. And that's where estimating comes into play. And I know that here's a little disclaimer. I know that it's going to seem like we're doing a lot of this work estimating, and it's probably just easier for you guys to just solve and get the right answer rather than estimating. But once you learn the skill of estimating, this is actually something that you're going to do a lot in your life later on. When you go to like the grocery store and you only have a certain amount of money to spend, you'll be estimating as you're going around buying different items and seeing how much they cost. And estimating, once you master it, is actually quicker and easier than solving an actual problem. And so right now it might seem a little bit harder and like it's more work than just solving the actual problem, but that's just because you're just learning it. Once you actually know how to do it and you master it, then you'll understand that it will actually help you later on. So work with me here, follow along, and hopefully you get the understanding of this. So estimating basically is looking at a problem and figuring out and getting close to the right actual answer, but you might not necessarily need the exact answer. For instance, look at this problem here. Let's say that I sold 54 candy bars on Monday, and then I sold 37 candy bars on Tuesday. Well, if I want to get an estimate about how much I sold altogether, then I would add these numbers up, but I would round them first to the nearest 10. We practice a lot of rounding. When you estimate addition and subtraction, you're actually going to round the numbers that you're adding or subtracting to get an answer that is close to the actual answer. So for instance, I have 54 and 37, and if I want to get an estimate, I'm actually going to round 54 to the nearest 10, which rounds to 50. And then I'm going to add it to 37, which rounds to 40. 50 and 40, 50 plus 40 equals 90. So that's not the exact amount of candy bars I sold, but that's my estimate. That's close to the actual answer. So I can say that I sold about 90 candy bars in those 2 days. Now, let's say I wanted to figure out the difference between the 2 days that I sold. I want to look at Monday and I want to look at Tuesday and say, okay, well, how much more did I sell on Monday than I did Tuesday? And I want to get an estimate. Not an exact answer, but close to the exact answer. I would do the same thing. I would round 54. I would round 54 to 50. And then I would round 37. Again, it rounds to 40. And then I would simply subtract. 50 minus 40 is 10. So I sold about 10 more candy bars Monday than I did Tuesday. And again, that's not an exact answer, that's just my estimate. It's about or close to the actual answer. Let me show you another example. Let's take the Statue of Liberty for instance. I want to figure about how tall it is. Not the exact height, but just kind of get an estimate of about how tall it is. Well, I look here on this chart and I see that the base of the statue here, this part, is 154 feet. Okay? And then the actual statue itself, this part right here, is 151 feet. Now I can get an estimate by rounding to the closest hundred this time to figure out about how tall the Statue of Liberty is. So I look at my 151, and I know that because there's a 5 in the tens place, 151 would round to 200. Okay? And then I look at 154, and I say, okay, well again, I'm rounding to the nearest hundred this time for my estimate. So 154 rounded to the nearest hundred. Again, I look at the tens place, and I know that because there's a 5 there, and 5 or more we raise the score, that also would round to 200. So I add it together, 200 plus 200, and I come up with an estimate that the Statue of Liberty is about 400 feet tall. Okay, and that's just an estimate. That's not the exact answer again. That's just a quick estimate if I wanted to figure about how tall it is. Take a look at this next example, okay? This time I'm actually comparing the actual height of the Statue of Liberty right here which is 300 feet tall, to the other Statue of Liberty that is actually in France, which is 37 feet tall. And I want to find out, well, how much taller is the Statue of Liberty that's in New York City than the Statue of Liberty that is in France? And I'm going to estimate. I'm not getting an exact answer, but I'm getting an answer that is close to the right answer or about. I'm just quickly estimating. So again, I would take 305, and this time I'm going to round it to the nearest 10. So 5 is in the ones place, so 305 would actually round to 310 if I'm rounding to the nearest 10. And 37 is going to round to 40, because 7's in the ones place, 5 or more, I raise the score. So 30 would raise up to 40. So I'm going to subtract 310 minus 40, okay, is going to give me 0 here, 11 tens minus 4 tens equals 7 tens. Then of course I borrowed it, so I had a 2 up above, so 270 feet. So the Statue of Liberty that's in New York City is about 270 feet taller, bigger than the one that is in France. Okay? That's just an estimate again. That's not the exact answer, but it's pretty close to the actual answer. There are key words in our when we're looking at word problems. Again, remember we talked about key words for addition and subtraction, where there are also key words you want to look for to know that you don't have to find an exact answer, but that you are looking for an estimate or an answer that is close to the exact answer. Some of those keywords that you will see are about. I'm going to show you some examples of this in a second, but about and close to, and then of course the word estimate. If you see those words in a word problem, then you know that you are you don't have to solve and get an exact answer, but that you actually want to go ahead and round your numbers and get an estimate. And here's a couple of examples of what that looks like. Mr. G had collected 173 acorns on Monday and 233 acorns on Tuesday. About how many acorns did Mr. G collect in all? So again, you see that word about that's right there in blue. That's telling you that in this problem you don't need to get an exact answer, but you can go ahead and just get an estimate or get an answer that is close to the actual answer. And you would do that by rounding the numbers, 173 and 233. And in this case, it doesn't tell you what to round it to. It doesn't ask you to round it to the nearest 10 or round it to the nearest 100. So that would actually be your choice. Any answer, any estimate you came up with would be correct. Here's another example. Estimate how many more acorns Mr. G collected on Tuesday than Monday. So in this case, they want you to compare how many acorns Mr. G collected Tuesday versus what he collected on Monday. And they want to know what the difference was. Now, they're not asking you for an exact answer again. They're asking you for the estimate, the blue word estimate. So they just want you to get an answer that is about or close to the actual answer. One last thing when it comes to estimating, and that is whenever you see the word or words best estimate. That's really important, because if you see a word problem, or if somebody is ever asking you to give the best estimate, then you need to know that you need to round your numbers to the closest 10, because that's going to get you to your estimate to the closest answer. Let me take that Statue of Liberty example for problem for example. We looked at 151 and we rounded it to the nearest 100, which it became 200, right? And 154 rounded to the nearest 100 became 200 as well. And then we added that together and it became, the answer was 400. Well, now let's look at see what happens when we round to the nearest 10. When we round these numbers to the nearest 10, 151 rounds to 150. And then 154 will also round to 150 to the nearest 10. We add those numbers together and we actually get 300. That's a much different answer than 400. Well, when we actually look at the actual answer, let's erase this again. The actual answer is the Statue of Liberty is 305 feet tall. So you can see that when we estimated to the nearest 10, we got a lot closer to the actual answer. So when you round to the when you round your numbers to the closest 10, that's when you're going to get your best estimate. Remember that. Rounding your numbers to the nearest 10 gives you your best estimate. Alright, see you in class.